For this question, we want to use the properties of logarithms and the logarithmic property of equality to solve the logarithmic equation. So there are two main strategies for solving log equations. We've already listed here the property we're going to use, but I just want to compare the two methods that we typically see for solving log equations. So with log equations, one property we use is this property of equality, and that says log base b of m equals log base b of n. So what you see is a log with the same base on each side. And by this property of equality, we know that what's inside of the logs must be equal to each other. So it allows us to simplify the log equation. The other strategy is to start with a log equation and convert it to an exponential equation. So that does not require you to have logs with the same base on both sides. So we might only have the log on one side. And if you have this situation, you can convert it to an exponential and have b to the y equals m. That takes the log out of the equation, and then you're able to solve what you have remaining. So sometimes if you know those two strategies, you can use what you have in the problem to give you clues on what to do. So I notice that I have a log on the left and logs on the right, and so that indicates to me that I want to use this strategy because it has logs on both sides, logs with the same base on both sides. But before I can use that property, I need to have the log being isolated on one side of the equation, meaning there shouldn't be anything multiplied or added onto the log. So we have some cleaning up to do before we're able to implement this property. So what we're going to do is we're going to use some properties of logarithms. And there's two that we're going to use in this problem. One of them is the power rule for exponents. And the power rule for exponents deals with this situation where you have log base b of m to a power. And anytime you have a power and an exponential expression inside the logarithm, what you're allowed to do is you're allowed to take that exponent, that power, and move it into the coefficient. So you can write this as that power times log base b of m. Now, we're actually going to go the other way. We're starting with the right-hand side of this equation. We have a coefficient on the front of our log. I'm going to highlight it over here. So we have a coefficient of 2. And we're going to put that power, we're going to put that back into the exponent, back into the power. So that's one property we're going to use. On the other side of the equation, I notice I have addition here. And we're going to use a property called the product rule for logarithms. And the product rule for logarithms has log base b of m times n. So we have a product within our log. And we can write that as log base b of m plus log base b of n. And so you'll notice that addition on the other side. So we're going to go the other way. We have addition, and we're going to turn that into a single log with the product on the inside. So let's write our problem out and work on this example. We have 2 log of x plus 3 equals log of 8 plus log of 2. So we'll use that power rule for logarithms to move that coefficient of 2 into the power. So the left-hand side becomes log of x plus 3 squared. On the right-hand side, we're going to use that product rule for logarithms, where we can write it as a single log, and we're going to multiply what we have inside the log, so that's 8 times 2. So on the right-hand side, we have log of 16. And I'll copy down the left-hand side, log of x plus 3 squared. So now we have written each side with a log with the same base. In this example, no base is written, so we assume the base to be 10. So we're able to use this property of equality now, which says that the expression inside the log on the left, x plus 3 squared, is equal to the expression inside the log on the right, 16. So now the logs are gone, and we're able to solve the equation that's remaining. So this is a quadratic equation. I'm going to get rid of the squared by square rooting both sides. The square and the square root cancel each other out, leaving me with x plus 3. I forgot the square root over here, square root of 16. We get plus or minus 4. And now I want to get x by itself, so I subtract 3. That gives x equals negative 3 plus or minus 4. So we've got two answers. Negative 3 plus 4 would be 1, and negative 3 minus 4 would be negative 7. Now, before we're done with this problem, we do need to check our work. Logarithms have restricted domains. Log of a negative number is something that is undefined. Log of 0 is undefined as well. So when we check, we have to make sure that the solutions that we came up with are in the domain of our logs we have in the equation. So let me zoom out just a little bit so we can check. And we're going to check our solution of 1. We're checking x equals 1, and we're going to substitute that into the original. That's 2 times the log of 1 plus 3 equals log 8 plus log 2. And so what I'm checking is that we have a positive value inside the log to make sure that it's defined. 1 plus 3 is positive, so we're going to be able to keep that solution of x equals 1. Let's try the other solution of negative 7. And if we substitute that in, we have log of negative 7 plus 3. And negative 7 plus 3 is going to be a negative value. And log of a negative is undefined, so we have to throw that solution away. So the only solution to this equation is x equals 1. Thank you for checking out my videos. Have a great day.